Hello students, welcome once again to Chem is Try. In this video, we'll be solving question 2 of WASSCE 2023 elective chemistry. A part of the question says CO2 and SiO2 are both covalent compounds. Explain briefly why CO2 is a gas, whereas SiO2 is a solid under no ordinary conditions. This is a question from Intermolecular bond. And they want to just find out what forces hold CO2 molecules together and what forces hold SiO2 molecules together. Then you talk about which of the forces is stronger. That's all. So CO2 is a covalent molecule that are held together by the weaker van der Waals forces. To be precise, the induced dipole interactions. Weaker van der Waals forces, otherwise known as induced dipole forces. Whereas the SiO2 is a covalent molecule held together by a network of strong covalent bonds. And as usual, the network of strong covalent bonds is stronger than the weaker van der Waals forces. Therefore, CO2 will exist as a gas under normal conditions, whereas SiO2 will exist as a solid under normal conditions. It's because of their forces. And the ones holding the SiO2 together is stronger than the one holding the CO2 molecules together. So what they expect you to say is weaker van der Waals forces holding CO2 molecules together and network of strong covalent bonds holding SiO2 molecules together. Then after that, you tell us which one of them is stronger, and that's it. At the B part of the question, an element X reacts with bromine to form an ionic compound. An ionic compound with the formula XBr2. I. State with reasons the physical state of XBr2 at room temperature. Well, we said the compound formed is ionic. And when you learn the properties of ionic compounds, you will learn that ionic compounds are mostly solids at room temperature. So if you are asked, state with reasons the physical state of XBr2 at room temperature, XBr2 is solid. And the reason is that because XBr2 is an ionic compound. That's all. II. State with reasons whether X is a metal or a non-metal. X in XBr2. Normally, ionic compounds are formed between metal and non-metals. And we all know bromine is a non-metal. Therefore, X would be a metal. How do we put that one in perspective? X is a metal. This is because XBr2 is an ionic compound. And ionic compounds are made up of metal and non-metal. Since Br is a non-metal, X is definitely a metal. That's how you explain it. Then III. Predict two properties of XBr2 other than its physical state. Now we know it's a solid, so we can't say it's a solid at room temperature because we've already stated that one in the first point. But they are looking for other properties of ionic compounds. What are those? 1, XbR2 is soluble in water. 2, when you melt XbR2 or when you place XbR2 in water for it to dissolve, it's able to conduct electricity. 3, you can also talk about XbR2 having a high boiling point and a high melting point. You can choose any of these 3 properties as your 2 properties of XbR2 other than its physical state. The last part of the B part of the question says, state the charge of an ion of X. State the charge of an ion of X. Now, to answer that one, we need to know the group in which Br is found on the periodic table. And Br is in group 17 or group 7A of the periodic table. Now, group 17 elements normally have either 7 or 17 electrons in their outermost shell, meaning to achieve stability, they will always need an electron. So, Br needs an electron to be stable. Then we have 2 Brs over there. So, each one will need one. So, the total number of electrons needed is 2, which is telling us that the bromine, each bromine atom will have a charge of -1, and you will need 2 of them. And if they will need 2 electrons, that means X should be in the position to supply those 2 electrons. So the charge on the ion X should be +2, so that it can give one of the electrons to each bromine atom. That's it. So that is the B part of question 2. Let's move to the C. State the law of definite proportions. State the law of definite proportions. That law states that when 2 elements combine to form a compound, their masses in that compound are always in a fixed ratio. This is what we mean by the law. If you have CO2, CO2 is always made up of carbon and oxygen. But what are the ratio of the masses of carbon and oxygen in this compound? We know carbon will have atomic mass of 12, and oxygen will have atomic mass of 16, but there are 2 of them, so that would be 32. So every CO2 molecule you meet has 12 grams of carbon mixed with 32 grams of oxygen gas. And we can reduce it further by dividing through by 12. You get 1:2.67. So in every carbon dioxide molecule, the ratio of the carbon to the oxygen is 1:2.67. That is what this law is trying to say. That when we have 2 elements coming together to form a compound, always the masses of each element in the compound are in a fixed and definite ratio. II. What volume of stock HCl with percentage purity of 36% and relative density 1.18 would be required to prepare 2.0 decimeter cube of 0.25 mole per decimeter cube HCl? Take the molar mass of HCl to be 36.5 gram per mole. This is preparation of solution from liquid solutes. The solute you are going to use is HCl, and it is liquid. And what we will need is the concentration of the HCl stock solution. Then I will need to calculate the volume of the stock HCl that I will need to prepare a solution with volume of 2 decimeters cube and a concentration of 0.25 mole per decimeter cube. So let's put down our parameters. So we have our C1. This is the stock solution. That's our solution 1. Then this is the solution we need. And that is our solution 2. So our solution 2 we need should have a volume of V2 equal to 2.0 decimeters cube and a concentration C2 of 0.25 mole per decimeter cube. Our stock solution should have a concentration C1 and should have a volume of V1. But we were not given the concentration of the stock solution directly. Indirectly, we were given. We were given the percentage purity, the relative density, and the molar mass. And we can use just those details to calculate the concentration of HCl. How? There's this formula. Concentration is equal to purity times relative density over molar mass, and all of them times 10. This is the formula you use. And from this formula, our C1 will be equal to purity. The purity is said to be 36%, so 36 times relative density, 1.18, divided by the molar mass, 36.5, times 10. This is how you calculate the concentration, given the purity, the relative density, and the molar mass of the solution we have. So this should give us 11.638 mole per decimeter cube. So that is our C1. So the headache in this question was using the percentage purity and the relative density along with the molar mass to calculate the concentration of the stock solution. And after that, you can chip it inside. 11.68638 mole per dm cube. Now we can use our dilution formula. C1 V1 is equal to C2 V2. We are looking for V1. So our V1 will be equal to C2 V2 divided by C1. So we have our concentration 1 as, concentration 2 as 0.25 times our volume, 2 decimeters cube, 2.0, divided by our concentration 1, 11.638. That should give us a volume of 0.04296. And the unit is decimeters cube. We can round this one to 0.043 decimeters cube, which is the same as 43 centimeters cube. Let's check the last part of the question. So looking at question 2D, iron was added to dilute tetraoxosulfate 6 acid, and the mixture was warmed gently, and the gas was given off. The iron dissolved, and a pale green solution was formed. When more iron was added, the reaction eventually stopped, and some iron was left. That is the question. I. Write the formula for 2 ions present in the dilute acid. So let's try and understand the question before we start solving. So we have iron metals. Then we have dilute tetraoxosulfate 6 acid. Then we've added the acid to the iron. and the mixture was warmed gently, and the gas was seen to be coming off. The ion dissolved in the acid to form a pale green or a light green solution. And when more of the ion metals were added, the reaction stopped after some time. And when the reaction stopped, we realized some of the ion metals were present in the pale green solution. So the first part of the question is asking us to just write the formula of two ions present in the dilute acid. Remember, the question said write the formula. So if you just write the name of the ion, it's wrong. The formula is what they need. So the acid is H2SO4. So the formula for two ions present in there are H plus, hydrogen ions, and SO4 2 minus, the sulfate ions. Just this. Don't write the name in words, please. Just the formula. II. State why the mixture was warmed gently. We warmed or we heated the mixture gently to increase the speed of the reaction, or to increase the rate of the reaction, or to speed up the reaction. So, to speed up the reaction is our answer to why the mixture was warmed gently. III. What would be observed to indicate that a gas was being given off? In one of my videos, we talked about the preparation of hydrogen gas. That when a metal, a reactive metal, reacts with a dilute acid, we form a salt and the gas is produced. That gas is hydrogen gas. And we talked about how we would observe the gas, that we are going to see some bubbles in the solution. So, how we are going to observe that a gas is being given off? Bubbles will be seen. Bubbles will be seen. Just that. IV, name the gas. Ion is a metal plus sulfuric acid. The gas will be hydrogen gas. So you have to write the name. Hydrogen gas. Please don't write H2. That is not the name of the gas. The name of the gas is hydrogen gas. V. Explain why the reaction stopped. When more ion was added, the reaction eventually stopped and some of the ion was left. So the reaction is between ion and tetraodosulfate 6 acid. If the reaction should stop, then it means either the ion or the tetraodosulfate 6 acid has been exhausted. But in this case, we said some ion was left. That means the ions particles have not been exhausted, but rather our acid has been exhausted. So we can answer this question by saying that the reaction stopped because the tetraodosulfate 6 acid was exhausted. It got finished. That is why the reaction stopped after some time. VI. What is the name of the salt that gives the salt a green color? So just try balancing this equation. We are going to form FeSO4 plus H2. That is the balanced equation. So the salt responsible for that green color is FeSO4. But the question said, what is the name of the salt. So the salt is iron 2 tetraoxosulfate 6. Iron 2 tetraoxosulfate 6. Now these Roman numerals in parentheses are written as block letters. So if you write the I without these dashes up and below, it's wrong. If you write this I2 without it, it's wrong. They're supposed to be capital Roman numerals. This way. VII states the method or states a method that could be used to separate the excess iron from the green solution. So we have iron particles in the green solution. How do we separate them? We can just perform a simple filtration. So you can just write filtration or bifiltration. That's all. So the question looks very big, but the answers are very simple and straightforward. Now, this brings us to the end of this question 2. In our next video, we are going to solve the question 3. So this same WASSCE 2023. Thank you.